Hi everyone. In the last video, we introduced what a linked list is and wrote a function to create one. But we left a question unanswered. After the function finished executing, the linked list we get ends up with one more node than the size we originally specified. Okay, so how do we fix that? Alright, some of you might think, can we just move the dynamic allocation of head node into the function Excel? Let's give it a try. Okay, so since head node doesn't have an actual instance right now, so we can comment out the parts where we walked through to the end of the linked list. Okay, we will just keep the loop that appends new node. However, we still need the current pointer, but we will initialize it as a null pointer. Okay, so here we are still creating a new node at the beginning of each iteration. What we need to do next is, if it is the first node being created, we should assign it to head node, right? Then we just point the current pointer to head node and continue with the stand logic as before. So how can we do this? Here we can use a bool flag to indicate whether it is the first node created. Let's name it first, and with an initial value of true. Okay, and inside the loop, if first is true, then we assign the new node to head. Okay, and set its values. Okay, and point current pointer to the head node. Okay, and then don't forget to set first to false forward. For the rest of the interactions, we just put the existing logic inside an else block. Okay, and since these lines will do the same, I think we can just put them outside the condition. Okay? Alright, the algorithm looks fine now, right? Let's go back to the main function and comment out the dynamic allocation of head. Instead, we just initialize it to null pointer. Okay, and pass it to our create linked list function. Let's try running it. Why is the output empty? Let's try some manual debugging. We will add some print statements inside the functions to check what's going on. Okay, so let's print each node's value after creating the new node. Okay, we are printed the value of each node after assigning default values to check if the memory allocation and assignment were successful. Let's run this again. Okay. it looks like the loop is working fine. So what's the problem? If linking failed, we should still at least see the first node's value printed, right? After all, we explicitly wrote head equals the new node. This is exactly the core topic of this video, the double pointers. So what are double pointers? They are a data type designed to point the address of another pointer. Sounds a bit tricky? Let's break it down using our code. Okay, right now our function takes in a single pointer, but this pointer is not the same as the head pointer in main function. It is actually a copy of the head pointer. It means we have another pointer and it points to the same memory address. But since head in main function was initialized as null pointer, so this copy is also null pointer. And all the operations we did in the function only affect the local copy, not the original head. So after the function ends, head in main function remains untouched. Make sense now? So what should we do instead? We simply change the function parameter to a double pointer by adding an extra asterisk. This way, the function receives the address of the head pointer itself, allowing it to modify head directly. Inside the function, we just need to dereference the pointer when assigned node, like this. Alright, let's go back to the main function. Since our function now expects the address of head, we need to pass it with the address of operator. That way, the function can actually modify the original head pointer. Let's try running it again. Perfect. Now everything works as expected. In this video, we focused on using double pointers to refine the create linked list function from our previous video. This makes the implementation align better with its intended behavior and helps you understand how and when to use double pointers. In the next video, we will continue exploring how to traverse a linked list, a very common concept in both lead code and technical interviews. Okay, see you in the next video.